want to look in the back of the book, we'll do it anyways. It's going to be 7.2, number 6. Oh, it's not in the back of the book because it's an even number. Oh well. Little c is approximately 64. Okay, let's see the quick check on this. That's 20 is the smallest side, and smallest angle, small side out of these three. The biggest angle, 133. Opposite side, the biggest opposite angle, biggest side, 64. Out of these three is the biggest side. 5 seconds. Bam. Okay. We're almost done. Notice it takes a little bit of time. Since we figured out this triangle right here, we're going to have to figure out what this triangle is now. Okay. Same thing. This is going to be 27 degrees. We know that this is 27 because these sides are equal. That's 30, by the way. This is 30. That's 20 degrees. That's going to be 40 right here. That's fixed as well. This angle is going to be 180 minus 27. 180 minus 27. I should do that in my head, but I'm not going to. 153 degrees. So let's redraw the triangle out. Nice and neat. That's 40. That's 20. That's A. And then that's going to be B right there. So we're going to call this B prime. It's going to be 153 degrees. That's 20. 150 plus 20 is 173. C prime is equal to 150. This is also 30 right here as well. All we have to do is find little c prime. Big C prime, the angle, is equal to 153 plus 20 is 173, so it's going to be 7 degrees. 180 minus 173 is going to be 7 degrees. It's got a really sharp angle, notice that. Remember, this is a second triangle, so all we have to do this time is find C prime, little c prime. To do that, you can use the law signs to figure out what that is. Okay? So we found out two triangles. In this case, that's what's called the ambiguous case. Next one, I'm running out of paper here, so put some new paper. Mark it just right. And I said that I would do number 9 and 23. Number 9. Same process all over again. A this time is equal to 112.2 degrees, and little a is equal to 43.8 centimeters, and little b is equal to 22.3 centimeters. Notice in this case, a is greater than 90, so instead of drawing it this acute angle, is going to be an obtuse angle. It's going to be 112.2 degrees. And we don't know how long this length is, but this one's fixed. We know that small b right over here is 22.3. That's equal to little b right there. And a is 43.8. So definitely bigger than b. It might hit something like that. That's little a, 22.3 centimeters. And let's try to figure this out, see if it actually fits and makes a triangle. Of course it's going to make one triangle because, excuse me, why did I do that? Did that again. 43.8 centimeters. Got to get the numbers right. We notice that little b right there is 22.3. Since this is much bigger, little a is much bigger, it is going to make exactly one triangle. Therefore, one triangle. And we're going to try to figure it out. Let's draw it again really nice and neat. 22.3 43.8, and that's going to be 112. That's A, that's little a, and that's 112.2 degrees, and that's little b. And you can use the law of sines now. That's big B right there. Sine of big B over 22.3 is equal to the sine of 112.2 all over 43.8. You can cross multiply, solve for B. I'll actually work this problem just to the last of the, right before the end, and you can do the calculation from there. 43 times 0.8 times the sine of the angle B is equal to 27.3 times the sine of 112.2. To get rid of 43.8, we divide it by 43.8. To get rid of the sine, we take the sine inverse of that. So angle B, that's CRF, calculator ready form. So use the calculator ready form, and then you just punch it out in your calculator. You'll end up with angle B. You can figure out what angle C is now by using the angle sum theorem, which has to equal 180, and you can figure out what little c is afterwards. Okay? Good luck on this problem right over here. And let's do one of the number 23, I believe. Let's get number 23. I'm going to get you started on number 23 to try to help you out with this problem. He's going to give you a lot of these problems where you're going to have like ground speed, air speed, boating speed. Whenever the objects are in air or on water, you're going to use bearing. We talked a little bit about bearing and how it's used, and so since this is going to be a hot air balloon which is in the air, we're going to definitely use bearing, and there's different ways to denote bearing, and we're going to go over this problem. A hot air balloon is held at a constant altitude, ground speed. Oh, it's an airplane. Bad airplane. Okay, so you got an airplane. A plane is headed east, so it's going east this way with an airspeed of 340 miles per hour mph. Its true course, however, is at 98 degrees due north. If the wind current are constant at 55, so you have the 55 miles per hour wind speed. What is the possibilities for the ground speed of the plane? Well, it's trying to go at, it's going at 340 miles per hour, but the true speed is 98 degrees. The way we don't denote 98 degrees is starting at north, that's going to be 0 degrees. To the right is positive, so we're going to actually go just a little bit past into the fourth quadrant. So that's going to be 98 degrees. That's its true course because of the wind speed, and it's going 55 miles per hour. So we're going to draw it out a little bit differently. I'm going to draw it this way. That's going to be 340 right there. And its true course is going to be this way. And we don't know what that true course is. We do know something, this angle right over here though. Since this is 90 right here, it's going to be 8 degrees more. And the wind is going to push it either in this direction at 55, or it's going to push it in this direction at 55. So what you have to do is you have to figure out what this, I'm going to use pink this time. That's the true speed that you're going to try to figure out. Or the second situation is that's the triangle that you're going to figure out. So there's two triangles. Give you a little bit of a hint. Goes this way, or it's going to go straight down in the opposite direction. So you're going to have to figure out what this length is, or this length is. You have two cases, the ambiguous case. Again, this is going to be 8 degrees, 8 degrees. This is going to be 340, 340. That's 55. So I'm going to give you a little bit extra information. That's 8 degrees. That's 340. You have to figure out what this is. That's 55. This is also 340. This is what you're looking for. That's also 8 degrees right here. 8 degrees. And this is also 55. Hopefully that should be enough to get you started and finish this problem. It's a little bit more difficult. It's going east. It's got a wind that's going this way, which means your airplane's actually going a little bit slightly down, 8 degrees past 90. Or the airplane's going this way. You got a wind speed going in this direction instead of that direction. It's going to push you more, a little bit more. So you're going to have a faster speed, basically. Sometimes here a slower speed or a faster speed. You know that we only know that's 55 miles per hour. Good luck to you. Hope you do well on this section. Take care. Bye.